Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my Absolute Beginner Guide. As I stated at the beginning of all these videos, these Absolute Beginner Guide videos are intended for people who are brand new to Orbiter. You've found the program, you've got it installed and working, but you really don't know how to do anything with it. Now, these videos are intended to be watched in order because they are sequential. Things that I cover in this video assume that you've already seen the videos in the previous the previous videos in the series. So if you're happening up on my channel for the first time in this video, you're going to want to go back to video number 1 in the Absolute Beginner Guide and work your way forward. Certain terminology that I use and certain concepts that I go over in this video may be unfamiliar if you haven't seen the previous videos. Okay, now having said that, in this video, we're going to start learning how to go to the moon. Now, this is probably going to require 3 or 4 parts. I'm not actually sure. Maybe even 5 or 6. It just depends. One thing I'm going to start doing is I'm going to try to start keeping these videos under 30 minutes each. As people find the videos and I should say, when people subscribe to the channel and they see a new video in their video feed, I think when they're over, 50 minutes, an hour in length, they kind of tend to go, they shy away from them because that's a lot of time commitment. So I'm going to try to keep each video under 30 minutes. Now, in order to get started here, let me go ahead and switch camera views. There are different default scenarios that come with Orbiter, and the one that I'm going to recommend that you use is in the checklists folder. So if you go to your checklist folder, there's this quick start scenario. I'm going to recommend that we use that scenario. So go ahead and check that scenario, highlight that scenario, and click Launch Orbiter. And the reason I like this particular scenario is because it puts you on the runway at KSC in the Delta glider, and it's fully fueled and ready to go. So once this comes up, I personally don't like this particular 3D cockpit, so I press F8 to get to this view or the 2D cockpit, either one. Now, in order to get to the moon, there are a couple of things that we can take into consideration before we just simply, hit the gas pedal, so to speak, and take off. And one of those things that we can take into consideration is when we arrive at the moon, will the target position that we arrive at, which is going to be Brighton Beach, will that be in the sunlight or will it be pitch black? It actually is preferable if you arrive at Brighton Beach when it's daylight, when the sun is shining. And that's mostly because Orbiter, when you're on the dark side of a planet or when you're in the dark, it's very black. I covered this in one of my previous videos when I talked about rendezvousing with the ISS. We would prefer to set up our rendezvous with the ISS so that we dock when the sun is up, because we can see everything a lot better. And it's the same thing when we get to the moon. We want to get to the target when the sun is up. And this is actually quite easy to do. We have Map MFD up already by default, which is quite convenient, but we want to reference. This is something I don't think we've done this before. So we want to click the reference button, and this works the same way. You press the down arrow to get to the target you want, which in this case is the Earth, and then we tap the right arrow one time for the moon and then hit enter, and we are now referencing the moon. Now our target position is actually here. It's this gray box, but if we want to see it a little bit better, we can click target and then go down to spaceports and go to Brighton Beach and hit enter. And now we have Brighton Beach selected as the target, and you can see it a lot better. Now the day-night terminator shows clearly that Brighton Beach is in the dark, and this whole area over here that's kind of lighter gray, this is where the sun is shining, and it's also shining here, but this whole section of the moon is currently in the dark. If we were to leave today and head to the moon, the day-night terminator would move from east towards the west, but it would only get to about maybe here by the time we got to Brighton Beach. So Brighton Beach would still be in the dark. And since we don't want that, what we need to do is just simply advance time forward. And we can do that a couple of ways, but since we don't need to go forward a very since we don't need to go forward by weeks at a time, we can just simply press T a few times until we get out to say 100,000, and we can see that day-night terminator moving quite swiftly. And we want to bring it all the way over to where the Brighton Beach is in the daytime. And let me just show you what I mean. So right about there is good. Now you may be thinking that since it takes us a few days to get to the moon, wouldn't we want the day-night terminator to be back here? And you could do that, and that would mean that by the time you got to Brighton Beach, then the day-night terminator would have just crossed over Brighton Beach. But I find that doing that, you end up arriving at Brighton Beach basically when the sun is all the way down on the horizon, and when that's the case, the surface is still basically pitch black. So I prefer to bring the day-night terminator all the way over top of Brighton Beach. That way, by the time I get there, this day-night terminator will have continued to move forward another 3 days, and then the sun will be up higher in the sky, and the surface will be lit up much better. So that's just kind of a personal preference thing. And again, you can go anytime you want. You don't have to wait for it to be daytime. If you for some reason want to arrive when Brighton Beach is totally pitch black, you can do that. Okay, so enough about that. Now we need to find out when the best time to take off from Earth is going to be. Now there are a couple of things here that we can take into consideration, and one option that I'll mention briefly, and we're not going to do this, is what's called an off-plane transfer. It's a little bit more efficient, and it actually helps us get aligned with Brighton Beach a little bit better. But I think for the absolute beginner, the better way to do it is to take off and head to a heading of 90 degrees when the relative inclination between the Earth and the Moon is at its lowest, and that's what we're going to do here, so that's what I'm going to explain. So we're done with Map MFD here for now, so let's press Select and bring up Align Plane MFD. And now we're going to target the Moon, and this works the same way as if we would target the ISS. So we're just going to click Target, but instead of going to Spacecraft, we're going to go to Celestial Bodies, and then hit the right arrow key and Moon, and there we go. Now we can see currently our relative inclination between our position and the Moon is 38.55 degrees. That's very high, and if we were to take off right now and try to get into orbit around Earth, we would have a lot of plane change correction to make. And remember, plane change equals expensive, so we don't want to do that. So all we have to do now is we just want to warp time forward until the relative inclination is as low as it is going to get. Currently, the rate is showing positive 0.001, so that means that the relative inclination currently is going to get worse before it gets better. So let's just go ahead and warp time forward. We can see what's happening. You can see the relative inclination is increasing, and again, that's because the rate is positive. But as we go forward at 1,000, you'll notice what will happen is as the positional indicator will eventually get to a right angle with respect to the line of nodes. That's the AN and DN. Once that happens, the rate will go into the negative, and the relative inclination will start coming down. You can see here it's positive 0, now it's negative, now the relative inclination is coming down. So all we're going to do now is just continue to warp time forward until the relative inclination is as low as it will get. Now if you're using this scenario, then your date will be March 26th, 2010, the same as mine, and that means your relative inclination will get to the lowest point, the same as what you'll see here in my scenario. It's worth mentioning, though, that the best relative inclination you can get varies by several degrees depending on your launch date, and I won't get too much into that. But if you were to take off, I don't have the launch dates memorized off the top of my head, but there's a certain date in, I believe, 2006 or 2007, where you can actually get almost a 0.00 relative inclination from Cape Canaveral. You'll never get exactly 0.00 from Cape Canaveral because the orbit of the Moon, basically because of the latitude of the base, it's not low enough. But we can get, on this particular launch date, we can get down to, I believe it's 5 point something. And on other launch dates, it will be higher than that. There will be some launch dates where your relative inclination the best you'll be able to get will be something like 7 degrees, maybe even 8. But we can see here it's still coming down. And again, we know that it's coming down because the rate is showing negative 0.001. Once this says negative 0.000, then I know that the rate is that I know that the relative inclination isn't going to get much lower. And that just happened. Another indication that I have is when the positional indicator gets to a right angle toward the line of nodes, then it's as low as it's going to get. Currently, you can see that we're not quite a perfect right angle, so there's still a little bit more to go. So I'm just going to go ahead and warp time forward, but I'm going to back off all the way to just 10 or so, because we're almost at the point where the relative inclination is at its lowest point, so we don't want to overshoot. And if we overshoot by a degree or by a 0.01 or 0.02, that's okay, but we would prefer just to get it exact. See, the rate is still negative, so we're still coming down on the relative inclination. So I'm just going to continue moving the clock forward until we get to the point where it's not going to get any lower. So we're at 3.19, and we're very close now because this is at a right angle. So this is going to switch to positive anytime, and it just did. So we don't want to tarry any longer than this. We now have the lowest relative inclination that we're going to get, and every second that goes by after this, our relative inclination is just going to get slightly worse. So let's go ahead and get into orbit. Take a sip of water here. Now, I'm not going to go into too much detail here about getting into orbit because I'm assuming again that you've already seen parts, the earlier parts of these videos in the series. So I'm just going to do what I need to do to get into orbit. But I will explain the specifics of what we want to watch as we're on our way to orbit. So press plus and hold it. I'm going to go ahead and use the keyboard for this instead of the joystick. Now you will notice here you'll be thinking, wow, that's really, things are going terrible, but don't worry about this yet. Once we turn to 90 degrees, that'll straighten itself out. So we're almost at takeoff speed. Go ahead and bring up this view for a moment so I can see the ground. Okay, raise the nose.
Gear down.
Yep, I accidentally double-clicked G, or double-tapped G. Now I'm going to bank pretty hard to the right.
Gear up.
And I'm just going to, again, watch that velocity vector to make sure it doesn't dip below the horizon, but otherwise I'm just going to bank aggressively until I can get over to 90 degrees. Let me switch to the yellow. It's got a better contrast with the sky at the moment. And you'll notice the relative inclination is now coming back down. You'll roll out a little bit because the velocity vector is getting a little bit low. This is a lot smoother when you use a joystick, but I'm just using a keyboard. Okay, now as we're approaching 90 degrees, we want to roll out and we want to start watching our rate. Okay, there we are, we're at 90. And just like when we're going to the International Space Station, we want to keep our relative inclination as low as possible on our ride to orbit. And remember, our relative inclination, the lowest point was about 3.19, so we should be able to get somewhere in that vicinity. But basically, we just want the rate to be negative 0.000 or positive 0.000. Okay, now that we're in the proper heading, I'm going to press the delete key, which increases the amount of elevator trim that I have. I kind of look outside, you can sort of see here the elevators. And you can also see here the trim indicator. And I'm raising the nose. I don't want to raise it too much, because if you get too high in the atmosphere too quickly, what'll happen is that you'll just the atmosphere becomes too thin, and then you just kind of drop back down. So just you want to climb out of the thick atmosphere as quickly as possible, but you don't want to get up too high too fast. So there's a balance in there somewhere. But again, I talked about that mostly in the earlier video, so we won't cover that too much. Putting in a little bit of left roll just to correct that relative inclination. I noticed that it was going positive 0.00, and my relative inclination went from 3.31 to 3.32. So I'm putting in just a tad bit of left roll, and I'm going to put in a little bit more elevator trim. We can climb a little bit more than 30 degrees. But once we get up to, say, 15 kilometers or so, we don't really want to climb too aggressively at that point. Relative inclination's back down to 3.31, so I'm just kind of watching this MFD over here just to help me keep on track for my ride to orbit. Now I probably will do a little bit of time acceleration just again to keep the videos a little bit shorter. I don't like to do time acceleration on takeoff because again when you're in the atmosphere it's just much more difficult for orbiter to keep up with the calculations, and the vessel oscillates really bad, but we can get away with a little bit of time warp, and I'll do that again just for the sake of time on the video. So things are pretty stable now. You notice the nose is starting to come down. That's because our altitude's now higher. We're at 23 kilometers, and there just isn't as much, the air just isn't quite as thick up here, so we don't have the aerodynamics that we did when we were down, you know, at sea level. So let's go ahead and a little bit more left roll because I can see the relative inclination, the rate rather, is positive, and I don't want that. Actually, I'm rolling the wrong way. Let's roll the other way. There we go. That's better. Okay, now put in a bit of 10x. And let me roll back the other way because now the rate. And before I do this, each time I'm coming back to real time, so just kind of keep your eye up here on the time acceleration so you can see what I'm doing. So now I'm going to 10x. Velocity vector is dropping below the horizon. I don't really want that, so I'm going to put in a bit more up elevator. And again, it's okay if it drops below the horizon for a little bit. It just happens because we're too high in the atmosphere for our velocity. But as our velocity increases, we will have better aerodynamics, for lack of a better expression, and then our velocity vector will climb back up to the horizon. And you can also watch that in surface MFD as I covered in the earlier videos. You can see our vertical acceleration is now positive. So even though our vertical speed is negative, which means we are currently going down, since our vertical acceleration is positive, then we're starting to nose back up. You can see that happening here. The velocity vector is climbing, and you can see that happening here. And I'm just pressing insert a couple times to take out some of the elevator trim so that we don't have as much oscillation. And let's put in a bit of roll, just a little bit to keep our rate. Put in a little bit more insert just to bring the elevator trim down a little bit so we don't oscillate. Okay, and I'm just going to roll here a bit towards center. Okay, rate looks good right about there. Now I'm going to 10x for a while. See the velocity vector coming down. Vertical acceleration is getting closer to 0, so we'll only dip down for a moment, and then we'll climb back out. Now we're climbing back to real time so I can roll the vessel a bit. A little bit more time acceleration. And as we get to about 6,000 meters per second, then I'm going to go ahead and just do the rest of the flight at real time. I'm going to go ahead and bring up orbit MFD, and again make sure projection is ship, make sure distance is PEA APA, and in this case the frame doesn't matter. I'm going to go ahead and roll the other way a bit. That's actually the wrong way. And we're going to take out all the elevator trim. We don't need any more trim at all at this point. Okay, we're going to go for a target apoapsis of about 200 kilometers. So as we're approaching orbital velocity, I'm going to go ahead and back off the main engines. And we can get away with that since this is the Delta glider. In a space shuttle, you pretty much have to do your initial launch using the full power of the main engines because you can't throttle back the external tank. Or at least you can't throttle back the solid rocket boosters. Go ahead and back off the main engines a little bit more. And primarily the reason I'm doing this is because the time to the apoapsis is getting a little bit far out ahead of us, and we don't want it to be too far ahead of us. This just makes sure that we get a nice, smooth Nice smooth target. And the roll doesn't matter too much at this point. We're at 75 kilometers, so we're not getting too much use out of the atmosphere, but if we can get the rate to negative 0.000, we'll do that. I may be rolling the wrong way at this point. Let me think about it. Yeah, I'm actually rolling the wrong way. So let me roll hard the other way. With whatever trace amount of atmosphere we have left, we'll get a little bit of improvement on the relative inclination now that the rate is negative. Okay, eyes back over on Orbit MFD. I'm going to go ahead and finish getting the apoapsis out to 200. Just a little bit more to go. Noticing as I put in the main engine there,
rotation.
It's actually making my rate worse. So let me roll the other way and do the main engine. And then we'll bring the APA out to 200. And I overshot it by 4 kilometers because I had a little bit of engine left there, but that's okay. We'll be fine just like this. Now, I'm already at 22 minutes, and this makes for a pretty good stopping point when you get to when you get up into orbit. So I'm going to go, even though the video is only 22 minutes, I'm going to go ahead and stop the video here at this point, and then we'll pick up in the next part, taking care of the various things that we need to take care of in order to get set for going to the moon. If you like this part of the video, go ahead and hit the like button, please. If you like the channel, go ahead and subscribe to the channel. And I also have a Facebook page. You can get the link in the description down below. On my Facebook page, I always post my videos, and I post various pictures and other space-related things, so go ahead and check that out as well. And I'll see you in the next part. Terminology that I use and certain concepts that I go over in this video may be unfamiliar if you haven't seen the previous videos. Okay, now having said that, in this video we're going to start learning how to go to the moon. Now this is probably going to require 3 or 4 parts. I'm not actually sure, maybe even 5 or 6, it just depends. One thing I'm going to start doing is I'm going to try to start keeping these videos under 30 minutes each, as people find the videos, and I should say when people subscribe to the channel and they see a new video in their video feed, I think when they're over, 50 minutes, an hour in length, they kind of tend to go, ugh. They shy away from them because that's a lot of time commitment. So I'm going to try to keep each video under 30 minutes. Now, in order to get started here, let me go ahead and switch camera views. There are different default scenarios that come with Orbiter, and the one that I'm going to recommend that you use is in the checklists folder. So if you go to your checklist folder, there's this quick start scenario. I'm going to recommend that we use that scenario. So go ahead and check that scenario, highlight that scenario, and click Launch Orbiter. And the reason I like this particular scenario is because it puts you on the runway at KSC in the Delta glider, and it's fully fueled and ready to go. So once this comes up, I personally... Okay, welcome to another Orbiter 2010 video. And this video is going to be another installment in my Absolute Beginner Guide. As I stated at the beginning of all these videos, these Absolute Beginner Guide videos are intended for people who are brand new to Orbiter. You've found the program, you've got it installed and working, but you really don't know how to do anything with it. Now, these videos are intended to be watched in order because they are sequential. Things that I cover in this video assume that you've already seen the videos in the previous the previous videos in the series. So if you're happening up on my channel for the first time in this video, you're going to want to go back to video number 1 in the Absolute Beginner Guide and work your way forward. Certainly don't like this particular 3D cockpit, so I press F8 to get to this view or the 2D cockpit, either one. Now, in order to get to the moon, there are a couple of things that we can take into consideration before we just simply, hit the gas pedal, so to speak, and take off. And one of those things that we can take into consideration is when we arrive at the moon, will the target position that we arrive at, which is going to be Brighton Beach, will that be in the sunlight or will it be pitch black? It actually is preferable if you arrive at Brighton Beach when it's daylight, when the sun is shining. And that's mostly because orbiter, when you're on the dark side of a planet or when you're in the dark, it's very black. I covered this in one of my previous videos when I talked about rendezvousing with the ISS. We would prefer to set up our rendezvous with the ISS so that we dock when the sun is up, because we can see everything a lot better. And it's the same thing when we get to the moon. We want to get to the target when the sun is up. And this is actually quite easy to do. We have map MFD up already by default, which is quite convenient, but we want to reference. This is something I don't think we've done this before. So we want to click the reference button, and this works the same way. You press the down